Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to time response analysis of control systems. So here we are with another question where it is given that the transfer function of a system, basically the closed loop transfer function Cs by Rs is given by 81 by s square plus 6x plus 81. Okay, and we have been asked to find out the parameters such as undamped natural frequency omega n, damping ratio zeta, peak time Tp, and peak overshoot Mp. So we know that the basic format of a second order system is given by the closed loop transfer function Gs by 1 plus Gs Hs. Okay, omega n square by s square plus 2 zeta omega ns plus omega n square. This is the basic format of a closed loop transfer function of a second order system. So I have explained in detail about all the time response parameters, the zero order, first order and second order systems, the input and output relationship I have explained in detail in separate videos. So I request you to please watch all those videos first so that you understand this video in a better way. So here it is the output. Okay, it is equal to Cs and this is Rs. Okay, so this is the general format. So here if we compare these two relationships, closed loop transfer function, and compare the denominator, then the denominator, which is the important factor in this, which is called as the characteristic equation, 1 plus GSHS is equal to 0, that is s square plus 2 zeta omega ns plus omega n square, here which is equal to s square plus 6s plus 81. If we compare these two, then we'll have omega n square is equal to 81. That implies omega n is equal to plus 9 radians per second. This is the first parameter which we got, undamped natural frequency. Then the second thing is 2 zeta omega n is equal to 6. Okay, that implies zeta is equal to 6 by 2 omega n equal to 6 by 2 into 9, which is equal to 6 by 18, which is equal to 1 by 3, which is equal to 0.33. Okay, zeta is equal to 0.33. Okay, this is the second parameter which we calculated, the damping ratio zeta. Then the other parameters are peak time and peak overshoot. So peak time is the time taken for the output response curve to reach the first peak value, the maximum value. So I have explained in detail about these time response parameters with the output curve, so you can watch the video. So Tp is given by pi by omega d, where omega d is the damped frequency of oscillations. It is given by pi by omega n into root over of 1 minus zeta square. Omega d is equal to omega n into root over 1 minus zeta square. So it is 3.14 by omega n, which we calculated as 9 into root over of 1 minus zeta square, which is 0.33 square. Okay, so if we calculate, we are getting the value as the peak time, it is coming around 0.3695 second, which is 0.37 second, almost this 0.37 second. Then so we have calculated the peak time, TP. Then we have to determine the peak overshoot. So peak overshoot, we know that the output response curve, it reaches various peaks. So that value, that peak overshoot, it is given as, in terms of percentage, it is e to the power minus pi zeta by root over of 1 minus zeta square into 100. So here if we put the values, it will be e to the power minus 3.14 into 0.33, which is the value of zeta, by root over of 1 minus 0.33 square into 100. So here the result that we are getting, it is equal to, the value is so it is equal to 0.3336 into 100, which is equal to 33.36%. Okay, that is the value of peak overshoot. Okay, this. So here we were given this closed loop transfer function, which was a typical second order system. We compared the characteristic equation, we determined the value of the parameters omega n, that is the undamped natural frequency, then the damping ratio, and the remaining things, the remaining parameters which were dependent on these two were simple, putting the values in the formula and getting the answer. So here the important thing is identifying the system, remembering the general format of different systems, whether it is first order, second order, mainly it comes second order, and then remembering the formulas. Okay, so here we determined all the values.